Moving on, last part. Mass of dissolved Alka-Seltzer. So again, here, setup for this one was really similar to the water and the sugar. So we're going to show our water particle as a blue dot. What am I doing? Water. And then let's go, we'll go with this like purpley particle. This is going to be our Alka-Seltzer. Okay. Again, we've got our before and after with the vial and the cap, just like we did in the water and the sugar. Let me go ahead and put the mass data down here. This is 13.07 grams before, after 13.00 grams. So we have a loss of 0.07 grams. Now, this is really showing a loss of mass. That kind of balance calibration error, I would say, is within plus or minus 0.03 grams for the balance that we used. Really, in this case, for part 6, I really should have waited longer before I took the mass at the end. If you take a good look at the video, there's still bubbles that are forming in that vial. And the mass is going to keep going down as those bubbles come out of the solution that formed when the Alka-Seltzer dissolved. So, and really the only reason that I didn't do that is because as Mr. Sharkey and I were filming the videos, we were getting close to the end of the period and really need to get those things done. So we want to say that we had bubbles that formed and were released into the air. Okay. This was a gas of some kind, right? We don't really know what it is. We don't really need to know what it is for the purposes of what we're doing here, but we want to know, we want to say that this made the mass decrease. Okay. This also tells us that a new substance formed, which again equals a chemical change. Okay. The reason that the mass went, well, let's go ahead and do our particle pictures. So let me do these Alka-Seltzer particles. Let's just go with like 4 this time. And then our water particles. 1, 2, 3, 4, 5, 6, 7. And I'm going to draw a little line to represent our liquid level this time. Okay. Now, the mass decreased this time because that gas escaped. The reason why the mass went down is we weren't able to measure the mass of those gas particles on the balance. So I want to make sure that we understand that those particles are still there. They're still present. They just weren't able to be measured. So let's just kind of summarize that. Gas formed is present after, but unable to be measured by the balance. Okay. This gas is a new substance with the water and the Alka-Seltzer. Water and Alka-Seltzer. Okay. I'm going to take those 4 Alka-Seltzer particles, combine them with 4 water particles, and I'm going to show what's happening. So I know that I have gas that escaped. I also know that all of that gas didn't escape when I collected that mass of 13.00 grams. So here's what I'm going to do. I'm going to show 2 of these gas particles escaped into the air. Now, I didn't really give myself a ton of space to do this, but we can see those are outside of our vial, right? I'm going to show the other 2 particles down inside of my vial, and that's going to kind of represent that we still have some more bubbles that can come out, right? So I used a total of 1, 2, 3, 4, 5, 6, 7 water particles before. I want to show those water particles that remain in our after picture. So I've used 4. I need to put in 3 more. 1, 2, 3. Okay. And that'll do it for part 6, our massive dissolved Alka-Seltzer. Now, one of the biggest things we need to use all 6 parts of this lab as evidence for is one of the first things you probably learned about chemistry in your science experience in school, which is the law of conservation of mass. You notice, even though we had measured masses that were different before and after all of the changes that took place, we still have all of the mass accounted for. It was not created, it was not destroyed, it just changed forms. So this is going to be something that is ever present in anything that we're doing in chemistry. In every particle diagram that you draw, we always have to make sure that mass is conserved. So up next is looking at adding conservation of mass to our mass 3 levels diagrams. Thanks.